ever catch yourself staring at a problem, And like the longer you think about it, the closer you get to that aha moment.
Yeah.
Turns out AI might be onto something kind of similar.
Mm.
We're doing a deep dive today. It's all about this research paper. It's called S1, Simple Test Time Scaling.
All right.
And it's making waves
Yeah.
by showing that you can give AI models more time to process not bigger models, not more data,
Right.
just more time, and it unlocks these crazy levels of performance.
Well, that's really interesting because it seems to be like a challenge to the common assumption that AI advancement just hinges on like increase in the model size or the training data, right?
Exactly.
This paper suggests we might be like totally underestimating the power of the models that we already have if we just let them think longer.
It's like we've been so focused on building bigger brains that we haven't stopped to think, are we even using the ones we have to their full potential?
Yeah.
This reminds me of how OpenAI has been so secretive about their Model O1, which seems to do this whole thinking longer thing really well.
It does.
But this research is going for a simpler approach, which is, better for everyone, more transparent.
Well, absolutely, yeah. The lack of transparency around O1 has led to a whole bunch of people trying to replicate it.
Yeah.
And this research is kind of a step towards, like, demystifying test time scaling.
Before we get too far into it, I just got to share this funny little thing from the paper. Did you know that humans generate more power per unit volume than stars?
That's amazing. I did not know that.
Yeah, it's a random little detail, but it just kind of sets the stage for what this research is all about, making AI models into these, seriously powerful thinkers.
Mm-hmm.
And to do that, they needed the right fuel. So they built this awesome data set called S1K, and it's made to test an AI's ability to, reason through tough problems.
I mean, the quality of the data that an AI model is trained on is absolutely critical.
Oh, for sure.
And in creating S1K, the researchers, they stuck to these three key principles: quality, difficulty, and diversity.
Right. I love it. Okay, so for all those listeners out there that are wondering, how does AI training even work?
Yeah.
Let's break it down. Quality, that means the data's going to be accurate, no errors, so the AI isn't learning from, mistakes.
Exactly.
Then there's difficulty.
Right.
And that refers to, how challenging the problems are. They used questions from Stanford's Stats PhD qualifying exams.
Wow.
And even brain teasers that they use in quantitative trading interviews.
Oh.
Talk about making the AI sweat, right?
Well, definitely. And don't forget diversity.
Right.
That's critical.
Yeah.
Because it shows the model all different kinds of problem types and make sure that the AI isn't just good at one thing.
Mm-hmm.
It can generalize, right? It can adapt its reasoning skills to new challenges.
So it can handle whatever you throw at it, basically.
Exactly.
Okay, so let's get to how this whole thinking longer thing actually works. Their method is called budget forcing, and it's kind of like if a teacher gave a student extra time to double-check their work on a test.
That's a really good analogy. Imagine the model is working on a math problem.
Yeah.
It might come up with an answer, but it seems reasonable. But then with budget forcing, it's like hitting the pause button, re-examining its calculations, even going back if it realizes there's an error.
They actually give an example of this in the paper, Figure 3. You can see the model is going through the problem, it's about to jump to an answer, and they just insert this wait prompt.
Oh, wow.
It's like saying, hold on, buddy, let's think about this a little more.
Interesting.
And a lot of times that actually makes it improve the answer. It shows that extra processing time really lets it refine its reasoning.
Oh,
so how well did all this work?
Yeah.
They tested their model, it's called S132B, on some seriously hard benchmarks. One was AME 24, which is this notoriously difficult high school math competition.
Okay.
And the other one was GPQA Diamond, which is this data set full of PhD level science questions.
That's amazing. So what happened?
Well, the results are pretty impressive. On the AA, S132B actually beat out OpenAI's O1 preview model by up to 27%.
Wow.
Which is, that's a big deal.
That is huge.
Because it suggests that a simpler, more transparent approach can actually be better than these massive, less transparent models.
That's a huge win for open science and making sure that we can all collaborate on AI.
100%. But it's not just about beating the scores, right? This idea of extrapolation is super interesting too.
Okay. Yeah.
The model can actually go beyond what it was initially able to do by just continuing to think.
So it's like unlocking some hidden potential within itself.
It's finding new ways to think. Now, know what you're thinking, though. Is there a limit? Like, how long can the AI actually think for?
Right.
And you're right, there are some limits.
Okay.
The performance gains do kind of level off eventually.
Yeah.
And the model has, a limited amount of memory context window, it's called.
That's where it gets really interesting, because to get around these limits, the researchers have been looking at combining this thinking longer with thinking in parallel.
That's cool.
And that brings in some really cool concepts like majority voting and something called rebase.
And that's where we'll pick up next time. We'll see how these parallel techniques can push AI reasoning even further. All right, welcome back. Last time we were looking at how just giving AI models more time to process information, this technique called test time scaling can lead to some pretty surprising improvements in performance.
We were talking about remember budget forcing?
Yes.
Which lets a model pause and, reevaluate its reasoning.
Yeah, kind of like when we double-check our work on a hard problem.
Exactly. But as you mentioned, there are limits to what a single model can do, even with that extra thinking time.
For sure. And that's where the whole idea of combining sequential scaling with parallel methods comes in, like going from a solo thinker to a whole team working together.
Yeah, it's a great way to think about it, actually. Visualize it. Think about how we solve problems in the real world.
Okay.
We brainstorm, we consider all these different perspectives, bounce ideas off each other.
Yeah.
That helps us come up with more robust solutions.
Makes sense.
And, parallel processing techniques like majority voting and rebase, they try to do something similar, harness the power of multiple AI models.
So break it down for us. Majority voting, that sounds pretty simple, just like taking a vote from multiple versions of the model and going with the most popular answer, right?
Yeah. The basic idea is pretty intuitive, right? You have the model come up with a bunch of different solutions.
Okay.
And then you just pick the answer that shows up the most.
Like the wisdom of the crowds, but it's the same AI model.
Exactly, yeah.
So it's like boosting the model's strengths while like smoothing out its weaknesses a bit. What about rebase, though? That one sounds a bit more complex.
Rebase adds a whole other level of sophistication. It uses this thing called a process reward model to help guide the model to find the best solution.
Okay, a process reward model. Break that down for us. What is that exactly?
Think of it like a coach or mentor that's watching the model as it's reasoning and giving it feedback.
Oh, okay.
So instead of just randomly trying stuff, rebase keeps the model focused on the paths that'll probably work better.
So it's not just about finding a ton of answers and hoping for the best.
Right.
Rebase makes the thinking more efficient and targeted.
Exactly. And what's really cool is that it can actually address some of the limits that we talked about earlier.
Yeah.
Like, remember how sequential scaling eventually hits a wall in terms of performance?
Right.
Well, by spreading out the thinking across all those different model instances, we can basically expand the context window. Explore way more possibilities, give the model a bigger canvas,
This reminds me of how human teams, right? Like, they often do way better than individuals at tough tasks.
Yeah.
Because, everyone brings different skills to the table.
Of course, of course.
Solving problems that would be, impossible for one person alone.
Exactly. And the researchers in this paper, they didn't just want to develop these techniques.
Right.
They wanted to understand why they worked.
Okay.
So they did these experiments, they called them ablations, where they removed or changed parts of their method.
Oh, interesting.
To see what happened to performance.
So it's like trying to figure out which ingredients are crucial to a recipe, right?
Exactly. What can you tweak, what can you leave out without messing up the whole dish?
All that analogy.
And one of their key findings, it was that the data set they used, S1K, played a big role.
Of course, the data set.
Remember those three principles: quality, difficulty, and diversity.
Oh, right. Yeah.
Well, they found that if they trained the model on data sets that were weaker in one of those areas, performance tanked.
Oh, wow. So it's not just about having a data set, it's about having the right data set.
Exactly.
One that's perfectly made to challenge the model's thinking ability.
One that's carefully curated. They actually found that a random part of their bigger data set did really poorly.
Oh, interesting.
As did a subset that was more diverse but not as hard. And even just picking the hardest problems didn't work as well as using the whole S1K, which, balances all three.
So it's quality over quantity, not just in AI, but in how we learn too, right?
Yeah.
It's a reminder to be careful about where we get our info and to look for stuff that's accurate but also challenging.
Absolutely. And beyond the data set, they also found that their test time scaling method, budget forcing, worked better than other approaches.
Okay.
So that they compared it to things like conditional length control, where you kind of tell the model how long to think, and rejection sampling, where you keep getting answers until one fits in the time limit.
Right, right.
But those methods either didn't give enough control over the thinking time, or they made things worse.
So sometimes given the model more time could actually make it do worse. That seems counterintuitive.
It does, but it shows that just throwing more computing power at a problem isn't always the best way.
Yeah.
It's about using it strategically and understanding, like, the quirks of how AI processes information.
Now that we've, gone through all those technical details, I kind of want to take a step back and look at the big picture. What do these findings really mean for the future of AI? What does it all mean?
Well, the implications are pretty exciting. If we keep developing these techniques, right, for making AI reason better, solve tough problems, maybe even surpass us in some areas.
Yeah.
It's like the possibilities are endless.
It's pretty mind-blowing, but also a little scary, right? It feels like we're on the edge of a tech revolution, but we're still figuring out what that means, for society, our economy.
Absolutely. And one of the most fascinating parts of this research is that it, challenges us to rethink what intelligence even is.
Sure.
We always thought of intelligence as being about speed, right? Like, how fast can you solve something?
Right, right.
But maybe giving AI more time, like this research shows, lets them tap into a whole different kind of intelligence,
Yeah.
more thoughtful, more strategic.
So we're expanding the idea of intelligence, beyond our own limits.
Exactly. And remember, extrapolation. AI models doing better than expected just by having more time.
Yeah, yeah.
That's a perfect example. There might be all this potential locked up in these systems that we're only just starting to understand.
Okay, so now I'm picturing AI that can think about a single problem for, days, weeks, months even.
That's right.
Finding solutions we can't even imagine.
Exactly.
It's kind of wild. But it also makes me wonder, what's our role in all of this? If AI gets that good,
Right.
are we just going to sit back and watch, or will we find ways to work with these systems?
That's a really important question, and we, as a society, need to figure that out. This research doesn't tell us the answers, but it definitely makes us think
Right.
about the future we're building and the ethical stuff we need to address as AI gets smarter.
So for our listeners who are hearing all this, feeling that mix of excitement and maybe a little bit of anxiety about what's coming next,
Yeah.
what's the main takeaway here? What should they be thinking about?
The big thing is the future of AI isn't set in stone.
Okay.
It's not something that's just going to happen to us. We're the ones shaping it. By the choices we make, what we invest in, how we deal with these new technologies.
We have this opportunity and a responsibility to be a part of this tech revolution. We got to ask questions, demand transparency and make sure that AI is used for good.
For good,
Yeah.
right? And for anyone who wants to learn more, about the actual research we've been talking about, I'd say go check out the code and data. It's open source. The researchers made all that available.
That's awesome.
Yeah, they're committed to open science and collaboration.
It's a really good reminder that the future of AI, it's not happening in secret.
Yeah.
It's a group effort. We all have a role to play. Now, let's move on to the final part of this deep dive.
Okay.
We'll talk about, the potential impact of all of this on society and how it might change how we live, work, and interact with the world around us. All right, welcome back to our deep dive into AI and this wild concept of test time scaling.
Yeah, it's been a fascinating journey so far.
Totally. We've been talking about how letting those AI models process longer, think longer, can lead to some pretty incredible reasoning skills.
We've dug into all those technical details, like how budget forcing and parallel processing can really amp up performance.
Yeah, and how these methods kind of mirror how we as humans solve problems, right? Through collaboration and strategic thinking.
Exactly. But now I think it's time to shift gears a little bit.
Okay.
Move from the how to the why. Why should our listeners even care about all these fancy AI advancements?
Yeah, what's the big takeaway here?
Well, while all the technical stuff is super cool, I think the real importance of this research is how it could actually change our world, fundamentally. If we can develop AI systems that reason better, solve complex problems, maybe even do things we can't, the possibilities are pretty much endless.
It's both exciting and kind of scary, right? It feels like we're right on the edge of this huge tech revolution, but we're still trying to figure out what it all means.
Absolutely. And one of the most interesting things about this research is how it makes us rethink what intelligence even is.
Oh, that's deep.
We always thought it was about speed, right?
Yeah, how fast you can solve something.
Right, exactly.
Yeah.
But this research suggests that maybe, just maybe, when we give AI systems more time, they can tap into a whole different kind of intelligence.
Okay, so what, like a slower, more deliberate kind of intelligence?
Right, exactly. More thoughtful, more strategic, maybe even more creative.
So we're pushing the idea of intelligence beyond our own human limitations.
That's the idea.
Yeah.
And remember, extrapolation. Those AI models exceed expectations just because they have more time.
Yeah, that was wild.
It's a perfect example of this. There might be all this potential locked away in these systems just waiting to be unlocked.
Okay, so now I'm picturing AI that can spend like days, weeks, even months thinking about a single problem.
Right.
And coming up with solutions we could never even dream of.
Exactly. And that leads to a pretty big question.
Okay.
What's our role in all this? If AI gets that powerful?
They're like, are we just going to be spectators?
Yeah, exactly.
Yeah.
Or are we going to find new ways to team up with these systems?
That's a tough one.
It is. It is. And it's a question we all got to figure out together. This research doesn't give us the answers, but it makes us think about the future, about the ethical challenges we got to face.
So for our listeners, they're hearing all this. They might be excited, maybe a little nervous about what's to come. What's like the one thing they should keep in mind?
I think the big thing is this.
Yeah.
The future of AI. It's not some set path.
Okay.
It's not something that's just going to happen to us. We have a say in it,
Yeah.
By the choices we make, how we use this tech.
We got to be informed, right? Ask tough questions and make sure AI is used for good.
Exactly. And for anyone who really wants to learn more about this research, go check out the code and data. It's all open source.
I love that.
It shows that the future of AI isn't happening behind closed doors. We can all be a part of it.
Well said. I think that's a great place to wrap up this deep dive.
It has been a fascinating discussion.
Big thanks to you for breaking down this complex research in a way that we can all understand, and to our listeners for joining us on this journey into the world of AI. We're just scratching the surface here, but hopefully this deep dive has sparked your curiosity and maybe even given you a few things to ponder.